So the order of size of the nucleus is 10 power minus 15 meter, and he also says that the order of size of an atom is 10 power minus 10 meter. So the kinetic energy of alpha particles decreases initially and finally it becomes 0. So now the centripetal force expression is given by mv square divided by r, and the electrostatic force is given by 1 by 4 pi epsilon naught Ze into E divided by r naught. Why it is r naught? Because r naught is the distance between the nucleus and an electron. Hello everyone, welcome to session 1 of chapter 12 Atoms. This is Vati from Department of Physics, Vidhyaashram University College, the Temple of Excellence, Mysuru. Dear children, we all know about what is an atom. It is the fundamental particle of nature. So in this session or in this chapter, we are going to study about the constituents of atom and also the behavior. So let us understand an introduction topic, that is who proposed a term called atom, what atom basically, how it came into existence. So the first model of atom was proposed by J.J. Thomson. So he proposed that plum pudding model. So what does this plum pudding model says about? The positive charge of the atom is distributed throughout the atom, as you can see in the picture, and a negatively charged electron are embedded plums in the pudding. So this is what he proposed. The positive charge atom is completely distributed throughout the atom. Negatively charged particles are embedded like plums in a pudding. So Ernst Rutherford showed that the distribution of electrons and the positive charges are very different from this model. So he did not agree with the plum pudding model. So Rutherford showed that the distribution of electron and the positive charges are in a different manner. So taking the suggestion of this Ernst Rutherford, Giger and Marston, they performed an alpha particle experiment or alpha scattering experiment, and they gave a clear idea about how atom is constituted. Let us now study about the postulates of this Rutherford atomic model. So the first postulate says that the size of the nucleus. So the order of size of the nucleus is 10 power minus 15 meter, and he also says that the order of size of an atom is 10 power minus 10 meter. That is, the atom size is 10 power 5 times bigger than that of the nucleus. We all know that the nucleus is present inside the atom. The order of size of the nucleus is 10 power minus 15 meter, and the size of atom is 10 power minus 10 meter, which means the size of the atom is 10 power 5 times bigger than the nucleus. So this indicates that there is a lot of empty space in the atom, inside the atom. So the entire mass of the atom and its positive charge is concentrated at its center. So here we can see an empty space and the mass of an atom, entire mass of the atom, and also the charges, positive charges are always concentrated at its center, is the first postulate of Rutherford. He also says that the nucleus is surrounded by number of electrons. The electrons inside the nucleus will revolve in its own orbits, and the electrostatic force of attraction between the nucleus and electron provides necessary centripetal force. Because of this necessary centripetal force, the electrons revolve in their own orbits, and the protons and neutrons will present inside the nucleus, which is in the center, so that the electrons revolve in circular orbits around the nucleus because of the necessary centripetal force. So next important parameter we have to understand is impact parameter. What is impact parameter? It is defined as the perpendicular distance between initial velocity of the alpha particle and central line of the nucleus. See, this is a nucleus and this is the central line. So here we have to see the perpendicular distance between the initial velocity vector of alpha particle. So the initial velocity vector and the central line which is passing through the nucleus gives us an idea of impact parameter. We have another important term in understanding this behavior of an atom, that is distance of closest approach. What does it mean? When a beam of alpha particle is projected towards the nucleus, alpha particles will scatter. These are all the observations of Rutherford atomic model. So when a beam of alpha particle is projected towards the nucleus, you can see here the alpha particles will scatter. So when an alpha particle is directed towards the center of nucleus, here you can see here, this is the nucleus. When an alpha particle is scattered or it is directed towards the center of the nucleus, on account of Coulomb's repulsive force, kinetic energy of alpha particle goes on decreases. So the kinetic energy of alpha particles decreases initially and finally it becomes 0. The distance between the nucleus, the center of the nucleus and the alpha particle, say for example, this distance is called as the distance of closest approach. So the distance between center of nucleus and the alpha particle where its velocity becomes 0 is called as distance of closest approach. We have an expression for distance of closest approach, that is, we have kinetic energy expression, that is half mv square, and the electric potential energy that is present between the particles, that is 1 by 4 pi epsilon naught Ze into 2e divided by r naught. So here Ze is the charge on the nucleus and 2e is the charge on alpha particle. So from this we can get r naught is equal to 1 by 4 pi epsilon naught 4 Ze square divided by mv square on rearranging the above terms. So here we have some merits of Rutherford atomic model. Advantages. So what is that? It could explain the large angle alpha scattering. I told you on the basis of Rutherford's suggestion, Giger and Marsden perform alpha scattering experiment and they study all these behavior. And according to this Rutherford atomic model, the large angle alpha scattering can also be explained. It's one of the merit of Rutherford atom model, and one can calculate energy of an electron using Rutherford atomic model. So we can find the energy of an electron with the help of Rutherford atomic model. Let us now derive an expression for energy of an electron using Rutherford's atomic model. To find the total energy of anything, we can get the concept of kinetic energy and potential energy. So by taking the sum of these two, we can find the total energy, and we are following the same method here in finding an energy of an electron by using Rutherford's atomic model. So for that, I have considered a nucleus, an atom, inside which the nucleus is present, plus Ze is the charge on the nucleus, r is the radius of circular orbit. So this is an electron which is present in its own orbit, outermost orbit. This is the velocity of electron. So r is the radius of circular orbit of an electron, v is the orbital velocity, where the electron is revolving around the nucleus with certain velocity in its particular orbit, and v is the orbital velocity. This electron possesses kinetic energy due to orbital motion, and it also possesses potential energy because of the presence of charge on the nucleus. So for the stable orbit, the total energy can be calculated as I have told. It is sum of kinetic energy and potential energy. So the total energy we are supposed to calculate, which is nothing but the sum of kinetic energy and potential energy. That is our equation 1. So from Rutherford's atomic model, we know that electrons revolve around the nucleus in certain orbit, and there is a necessary centripetal force for between the electron and the nucleus, and hence it will not come to another orbit and the next level. It will be in its own orbit. So there is a presence of centripetal force which is equal to electrostatic force between them. So now the centripetal force expression is given by mv square divided by r, and the electrostatic force is given by 1 by 4 pi epsilon naught Ze into E divided by r naught. Why it is r naught? Because r naught is the distance between the nucleus and an electron, where m is the mass of the electron and E is the charge of an electron. Now let us divide this equation by 2 on both the sides, and we get mv square divided by 2r is equal to 1 divided by 4 pi epsilon naught here we have, and if we divide this whole equation by 2, we get Ze square in the numerator divided by 4 into 2, that is 8 pi epsilon naught into r naught. So centripetal force is given by mv square divided by r is equal to, and the electrostatic force, as we have studied in the first chapter, it is 1 by 4 pi epsilon naught Ze square divided by r square. Now 1r and the r to the other side will get cancelled. Now we can divide this entire equation by 2, and we get mv square divided by 2 is equal to 1 divided by 8 pi epsilon naught r into ze square. So this can even be written as ze square divided by 8 pi epsilon naught into r, and that is my equation 2. So now according to the concept, the potential energy is nothing but the electrostatic potential at a distance r due to plus Zd, that is the charge on the nucleus and the charge on an electron. Now the potential energy is given by 1 by 4 pi epsilon naught into Zd divided by r naught into the charge of an electron, that is minus E. So this can be written as potential energy is equal to minus Zd square divided by 4 pi epsilon naught into r, or we can even write it as into r naught. This is my equation 3. Now we have got the equation for kinetic energy as well as potential energy. Now taking the sum of kinetic energy and potential energy, we can find the total energy of an electron. So what is the formula to find total energy? It is sum of kinetic energy plus potential energy. Since we have an expression for potential energy minus Zd square divided by 4 pi epsilon naught into r naught, so here we get Zd square divided by 8 pi epsilon naught into r minus Zd square divided by 4 pi epsilon naught into r. So what can we take common term here? We can take Zd square divided by 4 pi epsilon naught r from both these terms, and we remain with 1 by 2 minus 1. 1 by 2 minus 1 is minus half again, so we get Zd square with minus sign divided by 4 pi epsilon naught into r into half. So this can be written as E is equal to minus Zd square divided by 4 into 2 is 8 pi epsilon naught into r is an expression for total energy. Now suppose if we consider an hydrogen atom, Z is equal to 1. It is very important to substitute the value of Z for an hydrogen atom. Then the above equation becomes E is equal to, in the place of Z it becomes 1 minus E square divided by 8 pi epsilon naught into r is an expression for energy of electron in a hydrogen atom. So in this session we have learnt about Rutherford atomic model, alpha scattering, impact parameter, as well as the energy of an electron of a hydrogen atom. In the upcoming session, we shall learn about more concepts in the chapter atom. See you all in the next session. Until keep learning all of you. Thank you.